Good morning, student. I am going to start the first chapter, that is the ray optics and optical instrument of your second book. The first topic will be optics. What is optics? Optics is a branch of physics in which we study about nature, production and propagation of light. Means whenever light emits from the sun or from any luminous body, which what is the nature of the light and how light propagates in the medium, we have to see it. This clear means optics is, I'm writing here, it is a branch of physics. It is a branch of physics in which we study about nature, production and propagation of light. There are two branches of optics. One is the ray optics and another one is the wave optics. So I'm writing here branch of optics. There are two branches. One is ray optics. And second one is the wave optics. What is ray optics? Actually, under the ray optics, we study about the particle nature of the light. Means under ray optics, the ray optics is the study about the particle nature of the light. Means ray optics, it deals with particle nature of light. And it is based on the following assumption, that is the rectilinear propagation of light. Means light rectilinear propagation of light. Reflection and so. Whereas the wave optics, light is treated like a wave. Means light emits from any source in the form of wave. It propagates in the medium in the form of the wave. So wave optics means we have to see that it deals with wave nature of light. And interference, diffraction and polarization. We have to see under wave optics. So there are two branches of optics. One is the ray optics and another one is the wave optics. Is it clear? Now after seeing the branch of optics, we have to see the interaction of light with interfaces. Means whenever a ray of light will fall on any surface or on any interface, which kind of phenomena will be produced by the light? Let us suppose means we have to see interaction of light. We have to see interaction of light with interface. Now, let us suppose it is the first medium and it is the second medium, and a ray of light is incident on this surface. A ray of light is incident on this surface. So whenever a ray of light is incident on any surface, some amount of light is reflected, turned back into the same medium, and some amount of light is absorbed by the surface, and some amount of light deviates from its original path when it enters into the another medium from the one medium. Is it clear? So this property in which ray of light is reflected into the same medium is known as reflection of light, and this phenomena in which some amount of light is absorbed by this surface is known as absorption. And this phenomena in which ray of light deviates from its original path is known as refraction of light. After this, we have to see this property of light, that is the refraction of light. Is that clear? So I am going to write here refraction of light. Refraction of light. So I am writing here refraction of light. What is refraction of light? Refraction of light is such a phenomena in which whenever a ray of light comes from one transparent medium to another transparent medium, it deviates from its original path. As we are familiar with the property of light is that whenever light moves in one homogeneous medium, light always moves in a straight line path. But whenever medium changes, the ray of light will deviate from its original path. Means, let us suppose I am saying that it is your first medium and it is your second medium, and this is the boundary of the surface which separates the first medium from the second medium, and both of the medium in this case are transparent. Means this medium is transparent medium, and this is also transparent medium. So let us suppose a ray of light is incidenting at point O on this surface. Let us suppose a ray of light is incident on this surface at point O. So whenever it will move from one medium to another medium, it will deviate from its original path. Means this ray of light moves in a straight line like this, but it is deviating from its original path, coming in this direction. This phenomena is known as refraction of light. Means whenever a ray of light comes from one medium to another medium, it deviates from its original path. This phenomena is known as refraction of light. And the ray which falls on this surface is known as incident ray. And there is a line which is perpendicular to this point where ray of light is incident. Drawing this line, this is known as normal. And this ray is known as refracted. And this point is known as point of incidence. The angle made by incident ray with normal is known as angle of incidence and is indicated by I. and the angle made by reflected ray with normal is known as angle of reflection and is indicated by R. Is it clear? And this whole phenomena is known as reflection of light. Means reflection of light is a phenomena in which when a ray of light comes from one transparent medium to another transparent medium, it deviates from its original path. This phenomena is known as reflection of light. Is it clear? Now we have to see laws of refraction. We have to see the laws of refraction. First law is that incident ray, refracted ray, normal and point of incidence. Once again I am saying incident ray, refracted ray, normal and point of incidence all lie in the same place. Means the first law is incident ray, refracted ray, refracted ray, normal and point of incidence all lie in the same place. And second law is that the ratio of sine of incidence angle to the sine of refracted angle is always constant. Snell's law, which states that the ratio of sine of incident angle to the sine of refracted angle is always constant. Means sine I upon sine R is always constant, and this is indicated by mu and is known as refractive index of medium. Now we have to see what is refractive index of medium. Second question that we have to see is the refractive index. Is it clear? So I am going to write down the refractive index of medium. Is that clear? Refractive index of medium. Let us suppose a ray of light is coming from vacuum. Let us suppose the first medium is vacuum or air in any medium. So this is your incident ray and it is your refracted ray. This is incident angle I. This is angle of refraction. We know that the speed of light in vacuum or air is how much? Tell me. C, and its value is 3 into 10 to the power 8 meter per second. Whenever medium of light changes, the speed of light also changes. So this is the vacuum or air and this is any medium. So whenever light will come from vacuum to the air, the speed of light will decrease. Let us see the speed of light in medium is 0. So here the refractive index of medium that is always taken with respect to air or vacuum. Means whenever we are going to find out the refractive index of any medium, so we have to assume that the first medium or the ray of light is coming from vacuum or to air into that medium. Is it clear? Means I am writing here refractive index of medium will be equal to the ratio of speed of light in vacuum or air to the speed of light speed of light in medium. What is the speed of light in air or vacuum, my dear student? The speed of light in vacuum or air is c, and the speed of light in medium is v. So mu medium will be equal to c upon v. This is the refractive index in term of speed of light. Now let us suppose the wavelength of light in vacuum is lambda naught, where the wavelength of light in medium is lambda medium. So we know that speed is equal to distance upon time. Here we put the wavelength lambda naught, which is the wavelength in vacuum, and time, that is the capital T, time period. And we know that lambda naught into 1 upon T is frequency, so it will be equal to lambda naught into F. And here the velocity will be equal to lambda, this will be your medium into frequency. Means whenever a ray of light comes from one medium to another medium, the wavelength of light changes, whereas the frequency does not change, remain constant, you can also say. So in term of wavelength, means I am going to find out the refractive index of medium in term of wavelength. So what is refractive index of medium? Refractive index of medium in term of velocity is lambda, medium is equal to c upon v. Put the value of c. The c we have calculated is lambda naught into f. So I am keeping here the value of c. I am writing here 3 into 10 to the power 8 meter per second. Is it clear? The value of c is equal to how much? Tell me. Lambda naught into frequency f, whereas the v is equal to lambda medium into frequency f. This will be cancelled out. So this will be lambda naught upon lambda medium. Means refractive index in term of wavelength is lambda naught upon lambda medium. This is the refractive index of medium. And it is simply meaning that whenever refractive index of any medium is given, means we have to assume the first medium is vacuum or air. Means light is coming from air or to the vacuum to that medium. For example, let us suppose I am saying here the refractive index of, I am writing here, refractive index of water. Mu water is equal to 1.5. Means it simply, my dear student, the refractive index of water, it simply indicates that it is the refractive index of water with respect to vacuum or air. Means light is coming from air or vacuum to the water. Is it clear? And likewise, if I am writing here refractive index of glass, and it is 1.75. So we will put here c upon velocity of light into glass is equal to 1.75. And here the velocity of light in vacuum upon velocity of light in water is equal to 1.5. So refractive index of medium is always taken with respect to air or vacuum, where we know the speed of light. Is it clear? Now the second refractive index that we are going to see is relative refractive index. Relative refractive index. So I am writing here relative refractive index. Relative refractive index. Let us suppose it is medium 1 and it is medium 2. Let us say the speed of light in medium 1 is v1, whereas the speed of light in medium 2 is v2. And a ray of light is coming from one medium into another medium. So the relative refractive index medium is written as written by the symbol 1 mu 2, which meaning is that it is the refractive index of second medium with respect to medium first, with respect to medium first, and 2 mu 1 is equal to refractive index of first medium with respect to medium second. And what will be 1 mu 2? 1 mu 2 sometimes also written like mu 2 1, and this is also written sometimes mu 1 2. Is it clear? And the 1 mu 2 is speed of light in first medium to the speed of light in second medium. What is the speed of light in first medium? That is the V1, and the speed of light in second medium, that is V2. So 1 mu 2 will be equal to V1 upon V. And we know that, let us suppose the wavelength of light in first medium is lambda 1, whereas the wavelength of light in second medium is lambda 2. So here V1 will be equal to lambda 1 into F, whereas V2 will be equal to lambda 2 into F. Put the value, this will be lambda 1 into F upon lambda 2 into F, we get lambda 1 upon lambda 2. Means the refractive index in term of velocity 1 mu 2 will be equal to V1 upon V2, and in term of wavelength will be equal to lambda 1 upon lambda 2. Similarly, if I am writing here 2 mu 1, this will be equal to V2 upon V1, and likewise this will be lambda 2 upon lambda 1. Is it clear? Now we have to see the relative refractive index. We have to see relative refractive index in term of refractive index, in term of refractive index of medium. What is meaning? Look, let us suppose it is medium 1 and it is medium 2. The refractive index of medium 1 is mu 1, whereas refractive index of medium 2 is mu 2. And the ray of light is coming from one medium to another medium, and it is deviating from its original path. It is angle of incidence I, and it is angle of refraction. So 1 mu 2 will be equal to how much? Tell me. This will be equal to V1 upon V2. Where V1 is the speed of light in first medium and V2 is the speed of light in second medium. So what will be the value of mu1 in term of V1? This will be equal to C upon V1, and mu2 will be equal to C upon V2. So let us suppose I am multiplying C by numerator and denominator. This C upon V2 will be equal to mu2. And since mu1 is equal to 1 upon V1, so 1 upon mu1 can be written like V1 upon C. So this will be C upon V2 into V1 upon C. I am keeping the value of C upon V2, that is equal to mu2, and V1 upon C is written by 1 upon mu1. Finally, we get mu2 into 1 upon mu1. This will be mu2 upon mu1. Means 1 mu2 will be equal to, in term of refractive index, mu2 upon mu1. Likewise, 2 mu1 can be written as mu1 upon mu2. So this Okay, students, we are going to see now the cause of refraction. What is the reason behind refraction? Understand? So refraction occurs due to change in speed of light whenever it moves from one medium to another medium. Is it clear? Means is due to it is due to change in it is due to change in speed due to change in speed of light when it moves from one medium into other medium. Is it clear? So due to change in velocity, ray of light deviates from its original path whenever it moves from one medium to another medium. Now we have to see two major remarks. Remark one. Look. Whenever a ray of light moves from rarer medium to denser medium, the refracted ray bend towards the normal. Means when ray of light moves from rarer medium, when ray of light moves from rarer medium to denser medium, it bends towards normal. For example, let us suppose it is rarer medium and it is denser medium. The speed of light in rarer medium is c, and the speed of light in denser medium is. This is incident ray, and it is angle of incidence, and this is reflected ray, and this is angle of reflection. So what is 1 mu2? 1 mu2 is sin I upon sin R, and this is C upon V. We know that, so I'm writing here sin. The speed of light in rarer medium is always greater than that of the speed of light in denser medium. Then C will be greater than V. So C upon V will be greater than 1. It means sin I upon sin R will be greater than 1. So sin I will be greater than sin R. So from here, angle of incidence I will be greater than angle of reflection R. Means this angle will be always greater than angle of reflection R when ray of light moves from rarer medium to denser medium. This is the reason ray of light bends towards the north, because the value of C will be always greater than that of the V. So whenever we will divide V by C, we get the value greater than 1. Hence, ratio of C upon V will always greater than 1. In the case of when light comes from rarer medium to denser medium. Now, second remark is when ray of light moves from denser medium, to rarer medium, it deviates away from normal. Means let us suppose it is denser medium and it is rarer medium. The speed of light in denser medium is c, whereas the speed of light in rarer medium is c. So in this case, what happens? Look, let us suppose this ray of light is coming from denser medium to rarer medium, and it is angle of incidence I, and it is angle of refraction R. So what happens in this case? Look here. This is angle of refraction R. Since 1 mu 2, in this case, 1 mu 2 will be equal to sine I upon sine R, and this will be equal to V upon C. V upon C. Since C is greater than V, so V upon C will be less than 1. Means here, from here, sine I upon sine R will be less than 1. So sine I will be less than sine R, means I will be less than R. Means angle of refraction, this angle will be always greater than that of this angle. In the case when ray of light comes